All right. 1 second. Sorry about that. Okay. Good afternoon, everybody. So several students have been asking me to do some multiple choice for CSEC physics, right? For those of you who don't know me, I am the official author of the Cape Physics Unit 1 and Unit 2 study guides for CXC. Okay, so there are some teachers out there who are busy doing multiple choice exams with the students. Unfortunately, I cannot do an actual multiple choice exam here. What I will be doing the Specimen multiple choice exam that is actually in the syllabus. So this is in the public domain, right? So that is the paper that I'm going to be doing, right? So let's begin. So the first question on the paper, right, on the specimen paper, this is directly from the syllabus. Which of the following is a vector quantity, right? Now, a vector quantity, you all need to know what a vector quantity is, or what is the difference between a vector quantity and a scalar quantity. So, just for your knowledge, we have something called a scalar quantity, right? A scalar quantity has magnitude only. So it just has Gn. So a scalar quantity only has magnitude, right? For example, things like energy, that's a scalar quantity, right? So examples are things like energy, power, let's say mass, that is also scalar. We also have things like speed. Speed is also a scalar quantity, right? Distance is also scalar, right? So this is just review for you, right? So scalar quantities only have magnitude only. But then in physics we have something called a vector quantity, right? Now a vector quantity has both magnitude and direction, right? So this is what a vector quantity is. A vector quantity has both magnitude and direction, and examples of vector quantities are things like force, velocity, displacement, and even acceleration, right? So these are just some examples. You could get a question pertaining to this, right? So, which of the following is a vector quantity? Let me see if anybody's on here right now. Okay. So, mass. Mass is a scalar quantity, like I said, so mass is not the answer. Density is also a scalar quantity, so that's not the answer. And moment is a quantity, yeah, but it's not a vector quantity. So which of the following is a vector quantity? Momentum is a vector quantity, right? Momentum, if you recall, the formula is mass by velocity, and direction is very important when we are dealing with momentum, okay? Now let's look at the second question. The second question is asking us which arrangement gives the greatest resultant force acting on the block. Now, your resultant force is your combined force, right? So in this in part A, my resultant force here, because the forces are acting in opposite direction, the resultant force, we have a 50 Newton and we have 2 Newtons. So therefore my resultant force is going to be to the right hand side, right? So my resultant force is going to act to the right hand side, and it's going to be 15 minus 2, right? Which is equal to 13 Newtons. So that's my resultant force, and it's acting towards right. In the case of the second one, we have 6 Newton acting to the left, 6 Newton acting on the right. So therefore my resultant force is going to be 6 minus 6, which is 0, because we have two equal forces acting in opposite directions. in the case of part C now, we have 2 Newton acting to the right and 4 Newtons acting to the right. So therefore my resultant force obviously is going to act to the right. So it's 2 plus 4 Newtons, which is equal to 6 Newtons, and that is acting to my right. And the last one, my resultant force, we have 6 Newton acting this way and 6 Newton acting this way. So because they are acting in the same direction, it's going to be 6 plus 6, which is equal to 12 Newtons, but it's also acting towards the right hand side, right? And the question is asking which one gives us the largest resultant force. Obviously, the first one gives us the largest resultant force, which is 13. So my answer for part A is 13. Let's go on to the next one. Which of the following is a non-renewable energy source, right? So which of the following is a non-renewable energy source, right? So if we look at biomass, right, that is renewable, right? Wind is also a renewable resource. Now natural gas, now that one is non-renewable, right? So natural gas is non-renewable, right? The sun, however, is renewable. So a non-renewable resource, right, it's like a fossil fuel. When we use it, that's it. It's going to just be used up. So my answer has to be natural gas, right? Because they're asking for a non-renewable energy source, right? Let's go on to the next one, number 4. So in number 4, they give us some lamps. We have P, Q, R, and S, and they are asking us which lamp is most stable. So to make something stable, right, for something to be stable, one, it has to have a low center of gravity. Right? So it must have a low center of gravity, and also we want it to have a large base area. A large base area, right? Now, the reason for that is when we're looking at stability, we're looking at where the center of gravity is, right? So let's say, let's draw something here, right? Let's say I have something like this, a box, right? And my center of gravity is here. It's acting at this point. That's my CG, right? To determine if something is stable or not, we're going to have to draw a vertical line through the center of gravity, right? So therefore, our weight acts along this point here. Now, to determine if something is stable or not, we need to see if that vertical line we've drawn is within the base or outside of the base, right? If it's outside the base, it's going to be unstable. And if it's within the base, it's stable, right? So look at something here. If you're looking at the base for R and S, this is R and this is S, right? Both R and S are smaller than P and Q. So therefore, we can eliminate C and we can eliminate D. Now, when you look at P and Q now you need to look at the base area itself, right? That's here. You need to look at this. But you can also tell that because P is much larger, it means that it's going to have a larger mass, therefore a larger weight. So for this particular one, I would say the answer is A for the one that is most stable. Okay? Moving on to number 5. Alright, so number 5, which of the following is most suitable for measuring the diameter of a piece of wire, right? So you want to know which of the following is most suitable for measuring the diameter of a piece of wire, right? So a meter rule, well, let's say metric rule, well, that's too large. Remember, a wire is very small. A measuring tape, no. A vernier caliper, can't measure. You're looking at something, a diameter of a wire is in the order of millimeters. So what I would say for this one, I would say the micrometer screw gauge, right? Now, let's look at this one here. This is number 6. which of the following is the correct SI unit for pressure, right? So the first thing, before you can answer this question, we need to know what pressure is. So you all need to be able to state the definition for pressure. Pressure is the force acting normally per unit area, right? And this can be expressed as a formula, which is P is equal to F over A, right? Force is measured in Newton. Area is measured in meters squared, right? So the unit, the SI unit for pressure, we have two units we can use. We can say it's the Pascal, right? That's one unit, right? You know, some units in physics, we have a name for it. But it can also be expressed as Nm to the minus 2, right? So any one of those two units are equivalent to what pressure is. So obviously the answer in this case has to be B, because we have Pascal here, right? But if they had given us Newton per meter squared, then that will also be an answer, all right? So let's look at number 7 here. A vehicle with a uniform velocity of 10 meters per second is represented by the following graphs. Now, what I noticed in this question, they didn't specify what x is, right? So what I will assume that x in this particular case is distance, right? I will assume x is distance, and they are telling us it's a uniform velocity of 10 meters per second squared. Now, if you have a distance time graph and we are talking about velocity, the gradient of a distance time graph gives me velocity, right? So we are looking at these graphs here and we are trying to determine which one gives us a gradient of 10 meters per second, right? Now, I'm just going to look at a few here. So in this particular one, in part C, the gradient of this line is negative. So this is not what we are looking for. For this one here, we have a horizontal line. So my gradient is actually 0, right? So therefore my velocity is 0. So now what we really need to look at, we need to look at A and D. So we need to find the gradient of the line such that I'm going to get 10 meters per second, right? So if we just look at the graphs, we can see that A, the gradient of this graph, is going to give me 10 meters per second, right? And the reason we can say that is if we look here, this is 5 and this is corresponding to 0.5. So therefore, if we find the gradient, so the gradient, right, is equal to 5 divided by 0.5, which is equal to 10 meters per second squared. Sorry, meters per second, right? So the answer is A for this one. Now, let's see. Number 8. Which of the following is not a vector quantity? So we came back to vectors again. I spoke about what a vector quantity is. Which of the following is not a vector quantity? So if it's not a vector quantity, it's a scalar quantity, right? So look at something here. Force, we said, was a vector. Velocity was a vector. Acceleration was a vector. So therefore, the answer for this one has to be mass. Mass is not a vector quantity. It's a scalar quantity, right? So this is a scalar quantity. Number 9. Now, force is directly proportional to something, right? So when you have a question like this, you have to try to remember your mechanics, and you need to remember what formulas we're looking at here. So we know from Newton's second law that F is equal to ma. It's a very important formula that you all need to know, right? So force is equal to mass multiplied by acceleration. So therefore, from that equation, we can say that force is directly proportional to acceleration, right? So the question is asking, well, what is force proportional to? Well, it has to be acceleration, right? Number 10. So number 10, we have a cyclist riding down a hill. He applies brakes and eventually comes to rest at the bottom of the hill. Which of the following energy changes takes place? So you need to, when you get questions, you need to visualize what is really happening in some of these questions, right? So you have a cyclist riding on a hill. Kind of draw the hill a little steep here, but let's say there's a cyclist at the top of the hill, right? At the top of the hill, the type of energy that he's going to have is going to be potential energy. So at the top, we're going to have potential energy. Then he's going to cycle down the hill. Therefore, as he's moving, that potential energy is being converted into kinetic energy, right? And what is it? He applies, right down a hill, applies his brakes, and eventually comes to rest. So while he's going down the hill, he's applying his brake, right? So let's look at the answers. We're starting off with potential, and we're going to kinetic. So therefore, A, B, and D are potential answers, right? Now the thing is, when he's applying the brake, what is happening is that he is applying a force to oppose his motion, which means that what is happening is that the brake is going to start to become hot, right? Because you're doing work against friction. So therefore, for this particular one, I will say from potential to kinetic to heat, right? So I would say B for this particular one. So I'm going to say this, right? So the heat is coming from when he applies the brake is actually rubbing against the wheels, and therefore you're going to generate heat. Now, let's look at number 11 here now. They are asking us, they're saying acceleration can be defined as a rate of change of something, right? So acceleration is defined as the rate of change of velocity, right? Because A, acceleration, is equal to V minus U over T, right? V is final velocity. So V is final velocity. U is initial velocity. So therefore on top we're talking about a change in velocity, right? And T in this case here is time, right? So therefore acceleration can be defined as a rate of change of velocity, right? That's the definition for acceleration. Let's move on to number 12. Which of the following does the pressure of a fluid depend? Now, when we're talking about pressure in a fluid, there's a formula you all need to know, which is P is equal to rho G H, right? Where P is my pressure, rho is equal to the density of the liquid we are talking about, G is my gravitational field strength, right? So it's gravitational field strength, and H is my depth in the liquid, right? So if you have a container that has a liquid, right, and you want to know the pressure at this point here, I need to know the density of the liquid, right? I need to know what G is, which we'll assume to be 10, and we need to know the depth. The depth of the liquid here we're talking about is this. This is my depth, right? So right. All right, so it depends on the depth of the fluid. Yes, that is true. It depends on the density of the fluid. That is true. And it depends on the acceleration due to gravity, right? Now, you need to be careful here with this particular question, right? Now, they said the acceleration due to gravity. Now, in the formula, what is actually in the formula is gravitational field strength. That is what G is, right? So the pressure in a liquid actually depends on 1 and 2. All right? And by the way, that's what CSEC had for the answer for this particular question, right? So the wording is important. In the formula, G is gravitational field strength, and that is given as 10 Newton per kg, right? That's what it is. In this here, they are saying acceleration due to gravity, which is really 10 meters per second squared. In the formula, what we are talking about is gravitational field strength, right? So the answer is really C. Number 13, the period of a pendulum depends on, right? So this would have been like a typical data analysis question in your paper 2, right? You all need to be familiar with this formula, and this may have been a lab that you would have done in school as well. So T is equal to 2 pi the square root of L over G, right? That's the formula to find the period of a pendulum, right? For those of you who don't know what a pendulum is, you should. It's essentially a mass attached to a string, and when you displace the pendulum slightly, it's going to oscillate back and forth, right? So the time taken for each oscillation is given by this formula. So the period of the simple pendulum is, according to this formula, all it depends on the length, right? So it depends on the length of the string. It doesn't depend on the mass. It doesn't matter what the mass is, all right? I won't talk about too much of the others. Yeah, so T is dependent on the length of the string. Number 14. An airplane is traveling at a constant speed at an altitude of 1,000 meters above sea level, which is true. Again, every time they give you a question, you all try to visualize what's happening, right? So I have a plane. Can't draw too well, right? So let's say there's a plane here, right? So the plane is traveling, and this plane is actually at a height of 1,000 meters, right? And they are saying that it's traveling at a constant speed. So the speed is constant, right? Now you need to pay attention to the words being used in questions, because they can actually trick you in some of these questions. All right, so which of the following is true? The kinetic energy is increasing. Well, that can't be true, because if I'm moving at a constant speed, remember kinetic energy is equal to a half mv squared. But if my speed is constant, it means that my kinetic energy is constant, right? It has kinetic energy only. Well, it's moving, yes, but it's also 1,000 meters above the ground. So it's safe to assume that it has potential energy as well. In part C, it's saying it only has potential energy. That's not true. So I would go with D. It has both potential and kinetic energy. All right? Just give me a sec. All right, so let me continue. This is number 15. So which of the following is true, right? For a body, true of, which of the following is true of a body in equilibrium, right? So this is number 15. Right. So the sum of the forces in one direction is equal to the sum of the forces in the opposite direction. That's true, because if I have something like this, if I had a plank here, and I have an upward force F1 acting here, and I have another force which is F2 acting upwards here, and I have an next force here which is F3. If this object is in equilibrium, I can say that F1 plus F2 is equal to F3. Right? So my total upward force equal my total downward force. So therefore, this is true. The sum of the clockwise forces is equal to the sum of the anti-clockwise forces. Like I said, they can be very tricky with their questions. This is wrong, because they're talking about clockwise forces. Are we talking about clockwise and anti-clockwise? We are talking about movements. So therefore, 2 is wrong. That shouldn't be there. Then if we look at the third one, the sum of the clockwise moments is equal to the sum of the anti-clockwise moments, right? So therefore, this is true. And just to remember, if they ask you in the exam to explain what is meant by the moment of a force, it is simply the force multiplied by the perpendicular distance from my fulcrum, right? So this is a diagram you can use to explain what is meant by the moment of a force, all right? All right, so the answer is 1 and 3. So the answer is C, right? That's this one here. Now, number 16. We have 400 kilogram of methylated spirit, and it occupies a volume of 0.5 meter cube. What is the density? Well, this one is a straightforward question here, right? So density, which is rho, is equal to mass divided by volume. In this case, my mass is 400 and my volume is 0.5, right? And this gives me 400 divided by 0.5, that'll give me 800 kilogram per meter cube, right? So if you look at the answers, none of them give you that, right? But basically they're trying to see if you know what standard form is, right? So in the case of this here, I can write 800 in standard form as 8 by 10 squared kilogram per meter cube, right? So my answer is E, right? For the physics multiple choice exam, as far as I remember, you can go in with a calculator. The only paper you can't go in with a calculator is your maths exam, right? All right, so we have our next calculation here now. What is the gain in gravitational potential energy of a body of weight 2000 newtons as it rises from a height of 20 meters to 25 meters above the Earth's surface? So what they're trying to say is that we had an object here. It was initially 20 meters above the Earth's surface. So this is where the object was, right? And we moved it upwards. And we went up to a height of 25 meters. So from here to here, we went up to 25 meters, right? So therefore, the actual change in height of the object is really 5 meters, right? Now to find what I want, the gain in potential. So my gain in potential energy is equal to mg delta h, or let me just put h for you all. So mass, they didn't give us a mass, right? But they gave us the weight of the object. The weight is 2000 newtons. So you see this mg here in the formula. And we know that W, weight, is equal to mass by gravitational field strength. So therefore mg is already our weight. So therefore this is going to be 2000 multiplied by my height, and the height is really my change in height, right? So sometimes you might see this formula written as delta, my change in potential energy, is equal to mg delta h, right? Both are the same formula. What we're concerned about is the change in height. So it's really 2000 multiplied by 5, which is 10,000. And in this case, we're talking about energy, so it's 10,000 joules. So my answer will be C. Alright, so my answer is C for that one. Let's move on to question 18. Right. So in this question here now, they said when liquid in a puddle evaporates, its temperature changes. How does the temperature of the liquid change and why? So when a liquid in a puddle evaporates, the temperature changes. So we have some water in a puddle here, right? And they said the liquid in the puddle evaporates as it, right? So when it evaporates, its temperature changes. So it's evaporating, right? And they want us to explain what is happening here, right? So right. Now, when a liquid evaporates, what is happening is that my most energetic molecules are escaping from the surface, right? So these are the energetic molecules escaping from the surface. Now the thing is, the temperature of something depends on the kinetic energy of the particles that make it up, right? So therefore, if molecules are escaping from the liquid, what is happening is that my average temperature of my average kinetic energy of the remaining liquid decreases because my most energetic molecules have left. So what is going to happen is that my temperature is going to decrease as the more energetic particles leave the liquid, right? So the only answer that's saying that is A and B, right? And the reason now, well, I already said the reason. More energetic molecules leave the liquid. So the answer in this case has to be B, right? Let's go into number 19. Which scientists successfully showed the relationship between heat and mechanical work, right? So you all should know this. This is Joule, right? So Joule was the one, basically there's an experiment that you all need to know Basically we have a container that had water in it, right? So we had water, and there was a paddle wheel, right, that could spin the water basically. And what he did, he set up a contraption where you had fallen weights, right? And as fast as the weights fell, the paddle wheels began to spin, right? And what happened is that the temperature of the water increased by a certain amount. And what he noticed is that every time he dropped this mass from a particular height, the temperature change was always the same, right? So he showed the relationship between... Oh wait, hold on a second. I just realized I read this question wrong. No, that's my fault. Hold on. Just now. Oh yeah, okay. So, no, that's correct, right? No, I just saw Rumford here and mine just went back on something, right? Count Rumford had to do the Cannon-Boren experiment, right? And basically, he kind of disproved the caloric theory, right? So let's move on to number 20. So we have a thermostat in a domestic iron made from a bimetallic strip, right? So a bimetallic strip is essentially a strip that has two different metals, right? And they are riveted together. So when I say riveted, they are bonded together. So they're going to have things that bond them together, right? That's in the middle here. In the question, they said the strip is heated and the brass expands more than the iron. So if the brass expands more than the iron, the brass is on top, right? It's going to expand more than the iron. So therefore, they're asking us which one is it going to bend like. Now, if the brass expands more, then the answer has to be B, right? It's kind of common sense for that one. Number 21. Right, so the name given to the amount of energy needed to raise the temperature of 1 kilogram of iron by 1 degree, right? So basically they are telling us about specific heat capacity here, right? So the answer in this case is D, right? The definition for specific heat capacity is that it's the amount of energy required to raise the temperature of 1 kilogram of a substance by 1 degree, right? So that is specific heat capacity that they are talking about. Number 22. Alright, so Sharon painted half of a roof of a doghouse white and the other half black, right? So we're looking at the roof here. I haven't read the whole question yet, right? But half is painted white and half is painted black, right? She noticed that the half painted black dried quicker than the half painted white. So this side she's saying it dried quicker. The property that best explains why the half painted black dried quicker is that dark bodies are better, right? So they're looking for a term here, right? So black surfaces are good absorbers of thermal energy, right? That's what they're looking for here. So black surfaces are good absorbers. This is number 23 now. Alright, so bubbles of gas rising from a scuba diver below the surface of the sea increase in size as they rise to the surface. Their size increases because so let's see what's happening here, right? So you have a, let's say the surface of the water, this is air and this is water. You have a diver in the bottom of the pool and we have a bubble of air here. And what they're saying is that as the bubble of air goes up here, the bubble gets a little bigger, right? Now this question is about pressure, right? So let's look at the answers. Water pressure on the bubbles decreases. Yeah, that's true. As you move up, there's less water pressure on top of the bubble. So that's true. Water pressure on the bubble increases. Now that's wrong. Atmospheric pressure on the bubble decreases. Nope. No. Because atmospheric pressure, which is the pressure acting here, it stays the same. Right? So atmospheric pressure remains constant in this particular scenario here. So the answer has to be E. The water pressure on the bubble decreases. Alright? Let's see this one here now. So we have a clinical thermometer. It's designed so that it is very sensitive to small changes in temperature. Right? Now, you'll need to be able to know the structure of a clinical thermometer, and it has particular designs. So it has a large bulb, that's one. It also has a constriction that allows us to read the temperature. So it gives us time to read the temperature. And it also has a very narrow range, right? So I've seen questions where they've asked you about the range of the clinical thermometer. It's somewhere between 35 to 42, 43 degrees Celsius. Obviously, it doesn't go up to 100 because when water boils at 100, right? Our body temperature is not going to be 100 degrees Celsius, right? And it doesn't go down to 0 degrees because that is the freezing point for ice. So the range is between 35 and 42. Now, which of the following features should it have? A thick wall bulb and a wide bore. Well, obviously that's wrong. A thin wall bulb and a wide bore. That's still wrong. The bulb should be thin, yes. A thin wall bulb and a narrow bore. So this here is actually what the answer should be, right? So the design of a clinical thermometer, it should be a large bulb and it must have a narrow bore, right? Let's give me one. Alright, so where am I? Okay, so number 25, right? Alright, so in a YouTube video, Mr. Lee and his students heat a metal drum and it's then capped and dumped into a tub of cold water. The video shows that the drum is crushed. The gas law that best explains this is due to, alright, so first thing you all need to understand what they're talking about. So you have a container, this is a metal drum, and the metal drum is heated, then it's covered, and then they dump it in water, right? And they say that it is crushed, right? Right. So which of the following best explains? So you all need to know what each of the gas laws mean, right? So Boyle's law is PV is equal to a constant. Charles' law is V over T is equal to a constant. And the pressure law is P over T is equal to a constant, right? So for this particular one here, what we are talking about, if the metal drum is crushed, right, we mean that the volume is significantly going to change. And also we are talking about cold water. So you heated the drum initially and then you put it in cold water. So we are talking about volume and we are talking about temperature. So for this particular one, I would go with Charles' law. Okay. let's look at this one here now. An electric air conditioner maintains the temperature of the inside of an office building at 24 degrees Celsius. Which of the following measures could noticeably reduce the electricity bill? Right? So which of the following can reduce the electricity bill? Right? So the first one, reducing the temperature to 21 degrees. Well, that is not going to reduce the electricity bill, because if you want to reduce the temperature to 21, it means that I am removing much more thermal energy from the room. So therefore, I'm going to increase my electricity bill by doing that. So therefore, this is wrong. Next one is hanging curtains at the window. Well, that's a good idea. If you hang curtains by the window, it does two things. It prevents thermal energy from coming into the room, and it also prevents thermal energy from leaving the room, right? So hanging curtains in a room where you have AC is a good idea. Painting the roof of the building with aluminum paint, right? Now, aluminum paint on the roof makes it more shiny, and therefore what will happen is that a lot of heat is going to be reflected from the surface. So therefore, the third one is also a good idea. So the answer, I would say, is 2 and 3, right? So for number 26, I would say 2 and 3. All right. Let's go to number 27. So with number 27 now, what do we have here? We have a diagram. We have P, Q, R, and S, identical containers containing water. So they have water in each one. This is M, this is 2M, this is 3M, and this is 4M, right? And it's at a temperature of 80, 60, 40, and 20, right? What do we want here? Which of the following must lose the most energy to cool down to 10 degrees Celsius, right? So each of these liquids, they want to reduce the temperature to 10 degrees. And which one will lose the most amount of energy? So if we're talking about energy here, and we're just talking about a change in temperature, we're going to use the formula E is equal to MC delta theta, right? That's a formula you all need to know. So for each one of these now, we're going to have to work out what is my energy change. So in the first one, now all of them we're going to decrease the temperature to 10 degrees C, right? All of them we're going to 10 degrees Celsius. 10 degrees Celsius, right? So in the first case for P, my energy change, or the energy it's going to lose, is going to be M by C. Are they all the same liquid? Oh, they all can have water in them, right? So it's MC multiplied by my change in temperature, which in this case will be 80 degrees minus 10, which is 70 degrees. All right. So my energy loss in the first scenario will be 70 MC, right? For the next one now, it'll be 2M multiplied by C multiplied by my change in temperature, which will be, you're going from 60 degrees to 10, that's 50. So this is 100 MC. For the third one, it's going to be 3M multiplied by C multiplied by my change in temperature. You're going from 40 degrees to 10. So that is a change of 30. So that is 90 MC. And then the last one now, the mass is 4M multiplied by C multiplied by my change in temperature. I'm going from 20 to 10. So therefore, I'm just decreasing by 10. So that is 40 MC, right? So that answer in this particular case here is B. This one is the biggest one. It's 100 MC. So the answer is actually B. Right? So for this one, you actually have to do the calculation and work out the energy changes for each one of them and see which one is the largest. Now, for number 28, the table shows two pairs of readings taken from an experiment to investigate Boyle's law. So remember, you all need to know what Boyle's law is. Boyle's law is stating that PV is equal to a constant, or sometimes we see it written like this: P1 V1 equal P2 V2, right? Which of the following values is most likely to be measured if the volume is reduced to 20 cm cube? So basically, we are 20 cm cube. They want to know what is going to be my pressure, right? That's what the question is asking. Now, if you look at something here, we have a pressure and we have a volume. So if I multiply, remember the Boyle's law is PV is a constant. So therefore, PV in this first reading here will be 1 multiplied by 40. So my constant here is 40. For this one here, it's 1.3 multiplied by 30. So that is 1.3 multiplied by 30. You get about 39. Right? You get about 39. So therefore, if I take for this particular reading, which we don't know what the P is, we're going to say P multiplied by 20 cm cube, right? So I could use either the 39 or the 40, no matter. So P should be equal to 40 divided by 20. So therefore, P is equal to 2 kPa, right? So we're looking at an answer that's close to 2 kilopascal. So the only one that's close to that is actually this one here, which is 1.9, right? So please make sure you know what Boyle's law is. It's PV is equal to a constant, right? This next one here, number 29. Lightning is seen several seconds before thunder is heard, right? So you're trying to compare lightning. So you have a cloud here, and what they're saying is that we see the lightning before we hear the thunder, right? So thunder is produced after the lightning. No, that's not true. Light can pass through a vacuum, but sound cannot. That's true, but that's not the reason why we hear it. The speed of light is much faster than the speed of sound. This is correct, right? So light travels at a much faster speed than sound. So in the case of light, light travels at a speed of 3 by 10 to the 8 meters per second in a vacuum, right? In the case of sound, sound has a speed about 340 meters per second, right? So light travels significantly faster than sound. Number 30 now. Now, number 30, list the electromagnetic waves in order of decreasing wavelength, right? Now, you all need to know what the EM spectrum looks like, right? So, let's say, right, so usually if I have to do the spectrum, I'll start off with the visible in the middle. So you have the visible, so you have the visible part of the spectrum here, right? Somewhere in the middle, right? Then on the right hand side we have infrared, microwave, and radio, right? So you have infrared on this side, we have microwave, and we have radio waves, right? Then on the left hand side we have UV, X-ray, and gamma, right? So you have UV on this side, then you have X-ray on this side, and then we have gamma rays on this side here. Alright, so this is kind of what the spectrum looks like, and my wavelength increases in this direction. So wavelength increases this way, right? And therefore obviously wavelength decreases this way. So the question wants, list the EM waves in decreasing wavelength, right? So if you want to decrease your wavelength, let's see, X-ray, UV, so X-ray, UV, infrared, and microwaves. So A is wrong because we are increasing my wavelength there. If we go X-rays, infrared, UV, oh, that is mixed up, right? Next one is micro, UV, infrared. Oh, C is also mixed up. And if we look at D, we have microwave, infrared, UV, and then X-rays. So the answer in this particular case is D. All right. So I am going to pause at this point here, right? Because this is half the paper. Hopefully later on this evening I'll be able to do the rest of the paper. All right. So take care, guys.